We have a shape. The shaded area in figure 2 shows the plan view of a helicopter landing plat. Okay, the area consists of major sector A O B and of a circle center O joined to the triangle AOC given that AO. Okay, so let's label it. AO is 15 meters. Okay, this one is 15 meters. Okay, and BC is 2 meters. All right, CBO is a straight line. All right, what else? An angle ACO is 1.847 radians. All right, again ACO, no, 8.47, sorry, uh 0.6 radians. All right, 0.6 radians. All right, now it shows the angle, COA. All right, this angle over here is 1.847 radians to 3 decimal places. Okay, all right, so we need to find the angle ACO. Well, how we can find that? Okay, now you notice something, that we have a angle, okay, and a side opposite to each other. Same over here, we have a side and an angle opposite to each other. We can use sine rule, okay, over here. Yeah, so if we can use sine rule, if we can find this angle over here, that means that we can use the property of that the angles in triangle add up to 180 degrees. Okay, and then we minus this and this angle to find this our target angle. All right, so why, now you might be asking why we need to do this. Well, there is no information, okay, is there to directly calculate the angle ACO in one go. All right, also if we want to use cosine rule, this means that we should have this side here, this side here, yeah, and that side there to have this angle, but we don't have that side, so that's why we are considering to use sine rule, okay, first, and then use a property that the angles add up to 180, and then we minus zero point 0.6 and this angle which we find from cosine rule, or sine rule, sorry. Yeah, all right, so A is going to be cos of, no, not cos, sorry, it's sine. We are using sine rule. Yeah, so we have sine of 0.6. all right, 15, the opposite side, and we have the missing angle, which is sine of angle ACO, all right, over the side, okay, the opposite side, 15, 16 and 17. Okay, and if we can find ACO, we can minus it from 180, okay, and 0.6. so now since it is needed in radians, so we convert 180 radians is pi radians. All right, okay, so I'm going to solve in one go only. Okay, so pi minus, okay, you times by 17, okay, on both sides, so these cancel out. Okay, then you are left with this, yeah, sine of ACO. Well, what we can do is you can just take the sine inverse of it. Okay, all right, sine inverse of it. Okay, but here I would just do it in one go. Okay, it is possible that you can do this from your calculator, right? So sine minus sine of minus 1 is going to be sine of 0.6 over 15, all right, times by 17, all right, and minus, okay, so 0.6 radians, all right. Now it is read in radians, so make sure that don't forget convert your calculators into radian mode, because there's a high chance that you may make a silly mistake, all right. So sine of 0.6 over 15, all right, times by, all right, times by 17, all right. Okay, and minus 0.6, all right. All right. Oh, sorry, I forgot something. It should be sine. Yeah. Yeah. So if I sub this into in my calculator, you get 1.8. So for 1879, and so on. So since it's needed to 3 decimal places, okay, so we look over here. This is rounding up, so this is going to be 1.847 radians, all right, so hence shown, all right. Now find the total area of the helicopter path. Give the answer to meters to 3 significant figures, all right. So we need the whole area here. Now we find this angle. This is 18.57 radians over here. So we can find the area of triangle, because we have these two sides, which is required for the area of triangle, which is a half times AB sine of C. All right, so we have AB and sine C, this C angle, all right. No props there as well. Now we can use the to find this angle, this reflex angle, the major angle over here. What we can do is we can minus it from 360 degrees, which is 2 pi radians. So we can write 2 pi minus 8.47, and we can use the area of the sector, which is a half times pi, no, r squared theta, all right. So we need two areas, so what we are going to do is we're going to add these two areas. So a half times by a is going to be 17 times by 15, all right, times by sine of 1.847, and we have to add the area of sector as well. So half times by radius, the radius is 15, okay, all right, 15 squared, times by theta, the angle. So the theta we have found is 2 pi minus 1.847, okay. All right, so if you add the area, these both areas, let's see what you get. Let me sub this into my calculator. All right, so half times by 5 squared times by 2 pi minus 1.847, right? Sorry, yeah, this is going to give us 178.119. All right, 766. Okay, so we need three significant. Well, if it is three significant figures, we have our answer to 178 meters squared. All right. No, sorry, I just forgot the one there. So the answer is I'm getting is 621.738. Okay, so we have 622 meters square, right? Now it says find the perimeter of the helicopter landing pad. All right, so if we need to find the perimeter, we need this. Oh, sorry. I think so. Let me just minimize the size of it. Yeah. Okay, the thickness. All right. So we need this length, and this length. This length we already have. We can find this length because we have information on this angle and we have information on these sides. This means that we can use cosine rule. All right, and this for this side we can use the property that L, the arc length, is equal to radius times theta. All right, so yeah, so we can do radius times theta plus 2 meters plus square root of b square plus c square minus 2bc cos of a. All right, now if we substitute those all values, all right, so we have 15 times by the angle, which is 2 pi minus 847. All right, plus 2. All right, and we have b square. So b is 15 squared plus 17 square minus 2 times 15 times 17 times by cos of what, 8.1.847. all right, um right, it's the square root. I didn't have enough space. All right, right, so yeah, that's nothing much else. Make sure the values are substituted correctly. All right, there's so let me substitute this into my calculator. Right, so I get is 9.4098, so on. So it needs to again three significant figures, so we are looking here, so that is going to be 90.41 meters. Okay, all right, so question number 7. All right, all right, so we have this function here. All right, it touches its fx, it's a cubic function. All right, it touches x-axis, cut axis at x is equal to 4. Right, okay, touches and it passes through this. Find f of x. Okay, all right, so if we have information about roots of equation, we can form an equation. Okay, so if we have this x-intercepts, this means that we can convert them into brackets, and that give us the equation. That's basically the reverse process. Okay, all right, so we have that this a is equal to x minus 0. Okay, it's squared because whenever a cubic graph bounces, it's repeated root, and it is expressed as, bracket square. Right, um and we have an x intercept of x minus 4. All right, so basically this x minus 0 square is just ax squared. All right, uh and we have x minus 4. Right, and this is our f of x. Now you're probably wondering why we put a. Well, there is a possibility that graph could be stretched, all right, or sometimes graph can be stretched as well, or maybe squashed, yeah. So let's find the a factor. How we can find? They have given some information about the points, okay. So we use that. 10 minus 4 times by 120, so 10 squared, okay. 10 minus 4, okay, I get 600a, and then you divide both sides by 600. All right, so a is going to be 120 over 600, which is 1 over 5. So f of x is going to be 1 over 5 x squared x minus 4. All right, so sketch a graph of c2, okay. So this is a quadratic graph, so this is going to be now we first, to sketch a graph, we need x-intercepts. The x-intercepts are 0, and this one, 8 minus x is equal to 0, and 8 is going to be x. So we have the x-intercept. Y-intercept is obviously going to be 0, because times this x by 0, so it is going to be 0. Now the what's going to be shape of the graph? Well, if you expand this, you are going to get, okay, minus 1 point x squared. All right, the coefficient of x squared tells a graph it. If it's negative, the coefficient of x squared, it is going to be like this. If it is positive, it is going to be like this, okay. It's going to be u shape, but when it is negative, it's going to be like a n or type, something like that, yeah. So we have x is equal to 0, x is 4, all right, not 4, sorry, 8, and x-intercept is 0, so we draw a graph like that, yeah. And this is let's label the graph. Y is equal to 1.2x over 8 minus x, all right. Okay, so we have to find the points of intersection over here, okay. X squared times by x minus 4 is equal to the equation we have 1 2x over 8 minus x, all right. Now we expand these brackets, okay. X cubed, all right, and 105 times by minus 4 is minus 4 over 5x squared. So 1.2 times by 8 is going to be 48 over 5x. This one is going to be 1.2 times by 1 is just going to be minus 6 5x squared, all right. So we have all x's here, okay. What we can do is just collect the like terms on the side. So minus 4 over 5 we can add plus 6 over 5 x squared, okay, plus 6 over 5 x squared, all right. So this cancel out, plus 6 over 5, which is going to be plus 2 over 5 x squared, okay. And this is going to be minus 48 over 5x, okay, 0. So we can take a factor of x out, okay. What we can do is just we have a common denominator of 5, So we can cancel these out by times by 5, by timesing by 5, by timesing by 5, by timesing by 5, and this is going to give us x cubed, okay, plus 2x squared minus 48x is equal to 0. Alright, so this is a cubic equation and we can have a common factor of x. So we can take the x out. So we have x squared plus 2x minus 48x. Whenever these are points of intersection, we have to set the equations is equal to each other, okay? Right, so we can say that x is equal to 0, alright? Okay, and we need to solve this quadratic equation as well, okay, is equal to 0. So if we substitute 1 2 minus 48, so we have x minus 6 x plus 8 is equal to 0. So x is equal to 6 and x is equal to minus 6 minus 8, sorry, yeah. And now we have to substitute this into the original equation. So you can select any one of these, okay. I'm going to select this one, times by 6 times by 8 minus 6. All right, so if we substitute 6, we have 1.2 times by 6 times by 8 minus 6. All right, this is going to give 7205, which is going to be 14.4. So you can find that one point of intersection is 614.4. Now again, if we substitute right, so if we substitute minus 8, all right, so let's say if we substitute minus 8, so we have 1 over 5 minus 8 square. I'm selecting that equation, minus 8 minus 4, okay. So 1 over 5 times by minus 8 square and minus 8 minus 4, and this is going to give us minus 153.6, okay. So we have minus 8 minus 153.6, all right. And if we substitute 0, so 1.2 times 0 times by 8 minus 0, okay, so this is going to just give us 0, because anything times 0 is just 0. So this is 0 and 0. So these are our final answers over here. All right, so curve C has an equation f of x is greater than 0. Point lies on the curve 412. Given that f dash of x 3 root x and k x squared, where k is a constant, we have equation of tangent to the curve where c is a constant. Show that k is equal to 1 over 4. Right. Alright, so we have y is equal to 10x plus c. This is an tangent equation, okay. So this is basically in form of y is equal to mxc. So m of tangent is 10, okay. So we can extract the gradient from here. And you know, whenever we do f dash of x, okay, we basically substitute the x coordinate, okay, the x coordinate, and we basically find the gradient of the curve. All right, now here is you know no, we have the gradient and we have the x coordinate over here, which is 4, okay. So if we have 4 and we have the gradient, so this means that we have left with one variable, which is k, and we have to find value of that, okay. So we need to substitute okay, x coordinate 4 and set it equals to gradient, okay, to the f dash of x, because you should know that the gradient of the tangent is basically you find f dash of x, which is dy over dx. Okay, substitute the x coordinate. Okay, and then you find the gradient of the tangent, and we have the information about the x is equal to 4 and gradient is 10. Okay, and just we need to find this variable. Okay. We substitute. Okay, so this is f dash of x is 10 is equal to 3 root 4 plus, okay, times by 4 squared. Okay, so 4 squared is 16. Okay, so 3 square root 3 root 4 plus 16k, and 3 root 4, okay, is 6, because root 4 is equal to 2. Okay, and then square root of 4 is 2, and then you times by 3, which is 6. Okay, so 3 root 4 is 6. All right, 6 plus 16k, and we do 10 minus 6, which is 4, is equal to 16k, and divide by 16 on both sides. K is 4 over 16. Okay, now if you simplify, divide by 4. Okay, so 4 ones are 4, 4 fours are 16, and k is equal to 1 over 4. All right, now we have to find the value of say. Okay, that's easy. Okay, so point P lies on the curve, and we have okay, so basically we have to substitute these x and y coordinates to find the value of c. Okay, because why? Because this is a tangent to the p. This equation, it's it is on p. Yeah, it lies at p here. It basically like crosses at p, and that means that if we substitute the x and y coordinate, we can find the value of c. All right, so now y is 12, and we have 10 times 4 plus c. Okay, so 10 times 4 is 40, 12 plus a, and 12 minus 40 is c is equal to minus 28, and this is going to be 10x minus 28. Okay, now hence find the value of double f double dash of x. All right, so yeah, so basically we have to find dy dx again, 3 root x, okay, plus 1 over 4 x squared. Okay, this is f dash of x. Okay, now using the laws of indices, root can be expressed as a power of half. Okay, you should know this from chapter 1. All right, so because we can't just, it's not possible to find, root is there and we find f dash of x. That's not realistically possible. Okay, so we have 3 times by the power of half. So whenever you are differentiating, okay, you basically, yeah, you do is this coefficient times by power x and to the power of n minus, so just times by the power and you drop to the power of 1. Okay, so this is going to give us 3 over 2x is going to be a half, minus 1 is going to be a minus a half, plus 1 over 4 times 2, which is 1 over 2x. Okay, this is f dash of x, and now they are asking the value of p. All right, so now if we substitute the value of p, okay, again at p, so we have to substitute the value of 4 minus a half plus a half times 4, right? 3 over 2 times by 4 to 3 over 4, sorry, not 3 over 4, 3 over 2 times by 4 to the power of a minus half plus a half times by 4. Oh no. Okay, so this is going to give us 111 over 4. Okay, 11 over 4. Hence find f of x. So if you find f of x, we have to do the integration. Okay, so to go from f dash of x, we have to do integration. Okay, and to find the value of c, we need point p. All right, because it is lying on f of x. Okay, so we have f dash of x is 3x to the power of a half plus 1 over 4x squared. Okay, 3. Okay, now to integrate, okay, we basically add to the power of 1. Okay, we add 1 to the power, divide by the new power, which is basically the old power plus 1. Okay, so this is the new power. Okay, and then you divide this thing, this coefficient, and divide by the new power over here. Okay, so f of x is now going to be 3x a half plus 1 a half plus 1 plus 1 over 4x squared plus 2 plus 1 plus 2 plus 1. Okay, and make sure don't have to forget plus c. So 3 over half plus 1 is going to give us 2 and 2x, and then a half plus 1, so is going to be 3 over 2 plus 1 over 4. Okay, divide by 2 plus 1 is going to give us plus a half, no, plus, yeah, 1 over 12 x to the power of 3 plus c. Alright, so now we need to substitute those points into equation. Okay, 12 is equal to 2 times 4 to the power of 3 over 2 half times, okay, times by 12 plus c. Okay, so 2 over 4, okay, times by 3 over 2 to the power of 3 over 2 times 1 over 12, this is cubed. Okay, times by 12, not 12, sorry, it's 4. Okay, and this is what happens, and you do at the end of the question you get so much exhausted. C is going to be minus 28 over 3. So f of x is going to be 2x to the power of 3 over 2 plus a half x cubed minus 28 over 3. Okay, so yeah, so 2 to the power of 4, 3 over 2. Let me check that I've done it correctly. Okay, make sure you check your answers as well. This is one tip that yeah, it's 12, so yeah, got this correct. Okay, or what we can do is find, so there's function on your calculator. So basically, if you press catalog and you find the derivative, so if we put this equation, okay, to the differentiation, it can give us that did we find the integration correct or no. Okay, so yeah, so basically you go to the derivative and there's like you have to make a equation. There's a d over dx, and then there's a bracket, so you put this equation. Okay, this is a tip that you don't want to miss out. Okay, and you put x is, okay, 4 and 10. So I mean, if we get dy by dx is 10, so you got, yeah, so I put in my, got it as 10, which is correct, so this equation is correct. Okay, right, ninth question. Oh, oh, this one is tricky. This one is a bit tricky. Yeah, figure 4 shows c1 with the equation root 2x. Okay, a graph with the equation 12 minus root x. Okay, fully transformation that was drawn root x onto c2. So we can say that this, if you times root 2, okay, so basically this is root 2 root x. Okay, so this is basically, it's a stretch in y-axis. Okay, because it's outside. Okay, it's not affecting the x. Okay, by root 2. Okay, okay, and the graph with an equation minus root x onto c2, c2, oh, c1, oh yeah, onto c2. All right, so this would be it would be a translation, okay, by plus 12 units in y-axis. Okay, because it's outside the x. Okay, okay, all right, nothing much here. The graph C and P me at point P show that the x coordinate of a solution is this, and we have to find the exact coordinates of P. All right, so this is bit tricky question. How many questions are there? 10. Oh my god. So minus root x is going to be, no, minus root x, sorry. So this is my root 2x is equal to, okay, 12 minus root x. Okay, what we can do over here is we can collect the like terms of x on one side. This is going to be plus x is equal to 12, and this is positive root x. We add positive root x on both sides. Okay, so now what we can do, this we can factorize root of x, because this is basically this is equal to 12, and then we can factorize, take a common factor of root 2 plus 1, 12. Okay, now you can divide both sides by root 2 plus 1, divide both sides by root 2 plus 1, so 12 divided by root 2 or root 2 plus 1. Okay, so basically we have to rationalize the denominator over here. Okay, so basically you have to show your all stages of working over here. Okay, so just, you cannot like just rationalize it by the calculator, that won't work. Okay, so root 2 minus 1. Okay, so basically this is going to be root 2 times root 2 is 2, and this one is going to be plus root 2. Okay, that one was minus root 2 there, that should have come first, and this is going to be minus 1. So basically you multiply this the same way you do, like you expand this quadratic. Yeah, it's same thing over here. So you notice one thing, that this cancel out, and just we have positive 1 in the denominator. So this is just going to be anything divided by 1 is just the same. So this is the root x coordinates, the solution of this, hence shown. Okay, so we have to find the exact coordinates of p or I. So this is going to be squared. Okay, so what we can do is we can split the squares. Okay, now 12 squared is 144. Okay, now we have to expand this one. Okay, which is, okay, so let me change the color. Root, not green, let's just do green. Yeah, this one is basically root 2 minus 1, root 2 minus 1. This is going to be root 2 times root 2 is just 2. This is going to be minus root 2 minus root 2 plus 1. This is going to be 144 times by 2. 3 is going to be minus root 2 minus root 2. It's going to be minus 2 root 2, and yeah. So if you expand it, so you have 144 times 3 is 430. 2 plus, no, plus minus 144 times by minus 2 root 2 here. Oh, sorry. This is going to be 144 times 2 is minus 288 root 2. All right. So okay, so find the exact coordinates of p. Well, we have to find the coordinates of p. So if we, so y is going to be root and root x. Okay, okay, right. Okay, so we are finding the y coordinate, and the root x is equal to 12 over 12 root 2 minus 1. Now you're probably wondering why we don't substitute this x coordinate. Well, you cannot square root a third, and that would be, like, we cannot square root a third, and that would be, a rational. Okay, rational, you get something rational decimal, is rational number here. So instead, I just split it up, root 2 and root x, and we already know that root x is this, so we can just sub it in here, times by 12 times by root 2, 12 minus 1. All right, so 12 root 2. Okay, 12 root 2 is equal to root 2 minus 1. Okay, so 12 root 2 times by root 2 is going to give us 24, and 24 minus 1 is 23. Wait, did I, no, root x is 23. Okay, yeah, so I applied the, the BidMass rule was kind of incorrect. First we should like expand the brackets. Yeah, so root 2, this is going to be times by 12 root 2 minus 1. Okay, and root 2 times by 12 root 2, okay, is going to 24 minus root 2. Okay, still, okay, there's some problem over here. I'm not getting a correct answer. Okay, let's do it again. Okay, So we already know that root x is equal to, we can directly sub in, no need to just sub the only x value. Okay, so root 2 times by 12 times by root 2 minus 1. Okay, so this is 12 root 2, okay, times by, oh sorry, it was not big mass mistake, I just make some silly mistake. Okay, I didn't expand, I didn't like expand this 12 root 2 times by minus 1. I forgot to do that basically. Yeah, so 12 root 2, and this is going to be root 2 minus 11 minus 1. So 12 root 2 times by root 2, well, that is going to be 24 minus 12 root 12, and that is going to be y coordinate. Okay, yeah, so here's the coordinates. Okay, so not this one, this one over here. So 432 minus 288 root 12. Okay, and the y coordinate is 24 minus 12 root 12. Okay, all right, so we just sub in the root x over here. I just split it up because if we substitute x only, that is going to just give us rational number, and you cannot square root a third. Okay, so we already have root x, so why not, if we can substitute it, it would be much easier. All right, so that's question number 8. Bit tricky one there, I would say, bit hard there. Okay, last question. Find the exact number to the solutions with given k is equal to 4.5. All right, so 4.5 minus 1 x to the power of 6 plus 4x to the power of 3 plus 4.5 minus 4. You sub in, okay, the values. 4.5 minus 1 is 7 over 2 x to the power of 6 plus 4x to the power of 3. 4.5 minus 4 is just a half. Okay, is equal to 0. Now this is a hidden quadratic. Okay, so this means that we can rewrite this to the power of 2 and rewrite this to the power of 1. Okay, 7 over 2, okay, x 2 3. Okay, 3 times 2 is 6. Okay, oh sorry, I just switched it around. This should be 2. Okay, and this is 3. Okay, 3 times 2 is 6, and this is going to be x to the power of 3 times 1, because 3 times 1 is 3, plus a half is equal to 0. So now we have 7 over 2y square plus 4y plus a half is equal to 0. Okay, so now if you go to polynomial 4, you can do by quadratic formula. Okay, so let me do by quadratic formula. This is minus 4. Quadratic formula should know is minus b plus or minus b square minus 4ac over 2a, and this is minus b plus or minus 4 square minus 4 times 7 over 2 times by 1 over 2 over 2 times 7 over 2. So x is going to be equal to minus over 7, and x is going to be minus 1. It's not x, it's y. Yeah, it's y. All right, okay, so now we have a cube is equal to minus 1 over 7. Take cube root, okay, on both on sides. Okay, so a cube root of minus 107 is you just write it like this. Okay, or you can write like this. Yeah, cube root, you can just leave it like this only. Okay, yeah, you can leave it as it is. Okay, because the answer is going to be a rational number, and x cubed is equal to minus 1. You could take cube root, and anything to the cube root is going to be minus 1. Okay, if you do, because cube root of 3 minus 1, if you sub in, you get minus 1. All right, yeah, so here are those two solutions. Okay, we basically set it equals to the lowest power. Okay, x is equal to 3, x is equal to 3. Okay, the inside the bracket. Okay, and we put the y values here. Okay, and we find the value of x. Okay, this is basically a hidden quadratic question. Okay, okay, find the set values of k for which given the equation has no real roots. Okay, um okay, so we have to find the possible values of k for which the equation has no real roots. Okay, uh so k minus 1 x to the power of 6 plus 4x to the power of 3 plus k minus 4 is equal to 0. Okay, and it has no real roots. Okay, all right, so again we have to rewrite this in quadratic as a quadratic equation. So k minus 1 x to the power of 3 times 2. Why? Because we have to use a discriminant, and discriminant is, is for quadratic equation. Yeah, you can use only on quadratic equation when ax squared plus bx plus c is equal to 0. Okay, this one is going to be 3 to the power of 1 plus k minus 4. Now you get k minus 1 y squared plus 4y plus k minus 4. Okay, is equal to 0. Now the discriminant is going to be for minus 4ac less than 0. Okay, you should know this. Whenever there are no real roots, the discriminant is going to be less than 0. If there were one more root, 1 2 3 roots, it would be greater than 0. Now b is 4 square minus 4 times by a, which is k minus 1. Okay, this is a, this is b, and this is c, times by k minus 4 is less than 0. 4 squared is what? 16. Yeah, 16. Okay, minus 4, expand this bracket, k square minus 4k minus k plus 4 is less than 0. So 16 minus 4k squared. Okay, uh okay, so first we can simply collect the like terms inside. So minus 4, okay, k squared minus 5k plus 4 is less than 0. So 16 minus 4k squared. Okay, minus 4 times minus 5 is plus 20k. Minus 4 plus 4 is minus 16 is less than 0. Okay, 16 can cancel out. Okay, so we have minus 4k squared plus 20k is less than 0. Okay, so we can take k factor outside, we can take k common. Okay, This is going to give us 20k. We basically just factorized it. Okay, um is less than 0. Okay, so we know that k is 0, and yeah, minus 4k plus 20, 0. So we take 24k, divide by 4, divide by 4. K is going to be 20 over 4 is 5. Okay, so now we have to basically solve this quadratic inequality. Okay, now the shape of the graph is going to be like this. It crosses through 0 and 5. Okay, and we know that the y is less than 0, the whole discriminant equation. Okay, so whenever the y is less than 0, we are looking for the values over here, which means to here to here. So this means that 0 is less than k, k is less than 0, and k is greater than 5. So yeah, so that's our answer. Okay, so that's end of P1 paper. Hope you understood it. Yeah, so make sure, if I tell me if I have made any mistakes. Okay, I'm going to leave that up to you, because P1, if you know everything, you can do it. But the problem is, those algebra silly errors that really cost you marks. Okay, so yeah, I'm going to leave that to you. Make sure you, if you detect any mistake, just leave into my comment section. All right, so that's it for today. Okay, so yeah, peace out.